Welcome to this lesson on vectors. That is O-level mathematics. So we are going to look at vectors. So our first example says, find AB as a column vector for the following pair of points. For our first pair, we have A, which is 3, 2, and B, which is 6, 5. But briefly, let me first explain about how we get the vector AB, the formula that we shall use. So suppose we have a vector which begins from O to A, and then we have another vector to B, and then we are interested in getting a vector AB. So what we do here to get AB, that would be the same as getting AO then plus OB. But AO has changed the sign, the direction of vector OA. So we shall give it a negative OA. Then we add to OB. So it is indivisible to begin with the positive. So we shall write OB first, then minus OA. So if we want to get the position, the vector AB, we get position vector of B minus position vector of A. So likewise, if we can write A in terms of its position vector. So OA, we have it as 3, 2. And then OB, we have it as 6, 5. So meaning if we want to get AB, by formula we said this is OB minus OA. So this will be 6, 5. Then we subtract 32. So here it is simply we are going to get 6 minus 3, then 5. So this is going to give us 6 minus 3 is 3. Then 5 minus 2 is also 3. So we shall say AB is equal to 3 and 3. So that would be our first example. Then the second one, we have negative 2, negative 1, and B is 0, negative 2. So still likewise, AB is going to be OB minus OA. So our AB is going to be equal to 0, negative 2, when we write it as a column vector, then minus negative 2, negative 1. So go ahead, say 0, minus minus 2, then negative 2, minus 1. So negative followed by negative gives us positive, so this would be written as 0 plus 2, and the lower one, negative 2 plus 1. Then now our AB is going to be equal 0 plus 2 is 2, and negative 2 plus 1 gives us negative 1. So that would be our AB. The example, A is 0, 0, B is negative 3 and 6. So our vector AB, OB, position vector of B minus position vector of A. So this would be negative 3, 6, minus 0, 0. So this would be the same as negative 3 minus 0, then 6 minus 0. So it still gives us negative 3. AB. So that was about getting AB. So here we are going to our next, which is finding the gradient. So the gradient, we have a formula. So if we want to get gradient of the vector A, we get the root of x squared plus y squared. If our A is equal to x, y. So we take it to be in coordinate form. So here we are requested to find the magnitude of AB. So the magnitude of AB, A plus B. So we need to first get A plus B. So we are going to first deal with A plus B. So A plus B, 5 negative 2. Then we add this to negative 4, negative 6. It's going to give us 5 plus negative 4, which is the same as 5 minus 4. Then negative 2 plus negative 6, which is same as negative 2 minus 6. For A plus B is going to give us 5 minus 4 is 1, negative 2 minus 6 is negative 8. So that will be our AB. So therefore, magnitude of A plus B is root of 1 squared plus root of negative 8 plus negative 8 squared. So this will be root of 1 is 1, negative 8 squared is 64. So this will be the same as root of 65. Magnitude of A plus B. So find a magnitude of A plus B. So we can get root of 65 from the calculator. It gives us 8.0624. If we round off to 4, it's more. So that would be the magnitude of our vector A plus B. Then we also have, if we have A equaling 5, negative 2, B negative 4, negative 6, then C negative 1 and 3. So we are requested to find the magnitude of A minus 2B plus 3C. So we are going to first get the expression for A minus 2B plus 3C. So A is 5, negative 2, then minus 2 into B, negative 4, negative 6. Then we add 3 times C, which is 1, 3. So this will remain as 5, negative 2, minus 2 times negative 4, will be negative 8. 2 times negative 6 will be negative 12. Then add 3 times 1 is 3, and then 3 times 3 is 9. Then we can now add 5 minus 8. That one will be the same as 5 plus 8, then plus 3. Then we shall have negative 2 minus, which becomes plus 12 plus 9. So finally we shall have that A minus 2B plus 3C is equal to 5 plus 8 is 13, plus 6 plus 3 is 16. The negative 2 plus 12 is 10, plus 9 is 19. Then now our magnitude of A minus 2B plus 3C will be root of 16 squared 19 squared. Then we get this from our calculator. So 16 squared gives us 256. Plus 19 squared gives us 361 under square root. So we add 361 plus 256, and that will give us 617. Then we find the square root. The square root of 617 will give us 24.8395. This is rounded to 4 decimal places. Then lastly, if b is equal to -4 and -6, we find the magnitude of 5b. So we are going to still begin by multiplying. So we are going to get 5b, and this is equal to 5 into -4, -6. So that will be the same as 5 times -4, and 5 times -6. So this will be equal to -20. So that implies that magnitude of 5b to be equal to root of -20 squared plus -30 squared. This will be root of 400 plus root of 900. And finally, this gives a root of 1,300, and then we get a root of 1,300, and that gives us 36.0555 for decimal places. So we can still continue with this. So the magnitude of this will be root of -4 squared plus 3 squared. That will be equal to root of 16 plus 9, which is root 25. That is 5. The magnitude of 6/8 would be root of 6 squared plus 8 squared. That is root 36 plus 64. 36 plus 64 is 100, so we shall have root of 100. That gives us -512. We shall have -5 squared plus -12 squared, which gives us root of 25 plus 144. So we add the two. And that gives us root of 169, which is equal to 14. Then lastly, we have 10 and negative 10 and negative 10. So this would be root negative 10 squared plus negative 10 squared. So this would give us root of 100, 100 plus 100 gives us 200. So this would be root of 200. We can get the answer, root of 200 is 14.142, or alternatively we would say root of 200 is the same as 2 times 100 under root gives us root of 2 times root of 100. So root of 100 is 10, so we shall have 10 root of 2. So alternatively, we could have that. So thank you very much for watching this video. If you like it, please subscribe and share it.